topic is to know the basics of friction concept. Here you have the friction concept in the unit 5. So you have to know the basics of the friction concept, that is the outcome of this topic, and what are the objects here to you have to understand the friction concept and explain the types of friction and the applications and defining the limiting friction and the impending motion. So today's section, let us discuss about these objectives. So let us move to the friction. Okay, so the friction, this is the opposite force, which is a relative motion between the two surfaces which are contact each other, right? So that's why the friction is a force which opposes the motion of the object. So that's why here the force of friction is always acts in the direction opposite to the applied force. See here, the applied force is towards right. In the case, the applied force is towards right. See, this is the applied force direction, and the frictional force direction is the opposite direction. Okay, this is the applied force direction. See, the pushing force in this direction, and the frictional force direction is opposite direction. And the friction exists between the two surfaces due to the irregularities on the surfaces of the objects which are in contact. Why? Because why the friction is developed here? Due to the irregularities, means due to the surface roughnesses. Okay, so the friction always it is developed when the relative motion between the two surfaces which are in contact. Then only the friction is developed. So the friction is a force which is developed between the two bodies which are contact each other. And the friction is the force that opposes the motion of the object moving the past another. Okay, that is also you can define the friction definition like that. And I told you already the friction is mainly depends on the surface of the object. Suppose the surface is a smooth surface, the friction force is very less. And the surface is a hard surface, means the surface is a surface means here more irregularities are there. So in that case, the friction force is more. Okay, and at the same time when the two surfaces which are pressed together also it will give the greater force. Okay, so when the friction is also increases with the weight of the weight, so weight of the body if you are increasing, the friction also increases. Okay, the diagram you see here, is the some one person is skating here on the snow. So in that case, the smooth surface there is no very less friction. Here he is running on the hill, so here more friction is there when compared to the first one. And here the friction has some advantages as well as it has some disadvantages also. So that's why here some applications the friction is a plus point, and the some application the friction is a negative point. So some positives are there, some negatives also are there. So let us see the first one. What are the positive points? What are the where the friction is desirable? Okay, so when we are walking on the road, so that's why the friction is required when we want to walk on the road. So that's why here the friction here may the friction keep the main role during the walking on the road, and you are writing something on the paper. So in that case, we are gripping the pen. So that's why here the friction makes some important role during the gripping and during the holding or something. Okay, so that's why the friction is desirable in some application, and the friction is also some not desirable in some other cases. Here when you are walking on the hill, you are going up area, means hill area, so you have to apply the extra force. Why? Because so many the friction force is more in that case. Similarly, this is the hard surface. In the diagram, this is the hard surface. So if you want to move this object towards sideward direction, we need to apply some extra force. Why? Because the friction force is more. So this is the surface, the hard surface. Means surface irregularities are more. Okay. When compared to the smooth surface, we have to apply the more effort in the case. Okay. And due to the friction, the life of the machine parts also reduced. Why? Because the machine parts are contact each other. So when the machine parts are contact each other, so there is a friction is developed. So due to the friction, here the life of the machine parts will be reduced. Okay, that's why here we have to apply the oils or the greases to reduce the friction. Okay, and it is also not required in the mechanical parts where the two parts are for the machine needs. Right? In the some cases, we have to reduce the friction force Why? Because when the two parts are contact each other, the heat is generated and the wear and tear of the material also takes place. So that's why here in that cases we have to reduce the frictional force. Okay, so that's why the friction has some advantages and the friction has some disadvantages also. Okay, and I move to the next one, the types of friction. So let us see what are the types of frictions are there. Okay, so generally the friction we can classify the two types. One is the static friction, one is the dynamic friction. So we should know the difference between the static friction and the dynamic friction. What is the difference between them? Okay. Now let us see what is static friction. So when the body is at rest condition, the friction force which is exerted by the body is known as a static friction. So in the static friction, what is the state of the body? The state of body is at the rest condition. So when the body is at rest condition, the frictional force which is exerted by the body due to the contact between the surface, that the friction force is known as a static friction. Okay, and coming to the dynamic friction, when the body is under motion condition, the friction force which is exerted by the body is known as a dynamic friction. See here, the dynamic friction when the body is in the moving condition, then the friction force is exerted by the body. Okay. Now, in the dynamic friction, we further classified into one is the sliding friction, one is the rolling friction. So these two are the dynamic under the dynamic friction. What are those? One is the sliding friction and one is the rolling friction. What is the differences between the sliding friction and the rolling friction? Okay, let us see. Here, the sliding friction means here when the body which slides uh, with the another body, so the friction which is developed or which is exerted by the body is known as a sliding friction. And the rolling friction means the body which rolls on the another surface. In that case, the frictional force which is developed by the body is known as a rolling friction. Here, the three types of frictions are shown in here, and here there is no motion. Why? Because this is the static friction. So I told you the static friction means the friction force which is exerted by the body when the body at the rest condition. Okay, and the next condition is the sliding friction. Here the body is under motion. Here it is moving, right? It is under motion condition. So when it is moving condition, the frictional force which is developed between the contact surface, that friction is known as a sliding friction. And coming to the rolling friction, due to the rolling of this object, the surface of contact will give the rolling friction. But in compare the sliding friction and the rolling friction, the rolling frictional value is very less. So that's why we are preferring to design many trolleys. And suppose if you want to move something to from one place to another place, we are preferring to give the rollers. Okay, so that's why here the friction is very less. So resistance is very less. Why? Because the frictional force is opposite to the applied force. See here, the rolling friction is opposite to the external force, but this value is less when compared to the sliding friction. Okay. Now, how these all are the friction which is takes place between the dry surfaces. So that's why these all are also called called it as a dry friction. Okay. Now let us move to what is the fluid friction. Okay, the fluid friction which is takes place between the object and the fluid. Okay, now let us see in the first case the motion through the air. Okay, the fluid means air and the liquid. We call it as a fluid now. Now the motion through the air when aeroplane is moving in the sky. So here the some force is acting on the right side means the opposite direction. The air friction is developed to resist the motion of the aeroplane. So that's why here in the air the friction force which is developed is known as the air friction. And coming to the motion through the water, so it is the underwater marines and under other boats and ships when they are moving in the water or moving in the sea. So the opposite force which opposes the motion of these bodies, so that opposite force is known as a viscous friction. Why? Because the fluid develops the frictional force. Here, the opposite force is due to the fluid. Okay, here the opposite force due to the air. So that's why here the friction is known as a fluid frictions. And these are the some examples given for the types of frictions. And there are four types of frictions already we discussed here. The first diagram shows the rocks are there, and these are at rest condition with the stationary rocks. So that's why there is a friction developed in between them. So that type of friction is known as a static friction. And the second case, the persons which are traveling, moving on this one here on the snow, this trolley moves on the snow here. There is a sliding in between the surface and the object. So that's why here the friction which is developed between them is a sliding friction due to the sliding of the object. And coming to the this one here, this is the rollers. Here, some person is pushing this cart, right? So here, the friction which is developed between the roller and the surface is known as a roller friction or the rolling friction. Okay, and the rolling friction is which is less when compared to the sliding friction. And coming to the last one is the fourth example is here the boat is moving in the sea. So there is a resistance force by the fluid. So that's why this is the friction or the opposite force which opposes the motion of the body due to the fluid. So that's why it is also called it as a fluid friction. Okay, these are the different frictions which are developed in the real life example. And now I'll move to the topic limiting frictional force. Okay, so this is very important. You should understand what is the limiting frictional force. Okay, so let us see the definition of the limiting frictional force. The maximum frictional force that can be developed at the contact surface when the body is just on the point of moving is called it as a limiting frictional force. So once again, I'll repeat. The limiting frictional force means the maximum friction force that can be developed at the contact surfaces when the body is just on the point of moving. It's called it as a limiting frictional force. Okay. To understand the limiting frictional force, let us take one experiment or one example. See here, in that example, I will take one body, okay, and the body which is subjected to the force P. Okay, the force applied on the body is P, and when you are applying the force on the body P, the frictional force which is developed by the body is known as a means contact between the surface and the body. The frictional force is F. Okay. See the example. These are the three examples here. The first example, you are applying the force P on the body. So when you are applying the force P on the body, the frictional force which is opposes the applied force, the friction force which is developed, that is Fs. Fs is the frictional force opposes the external force P. Okay, but in that case there is no motion between the bodies. Okay, so that's why the frictional force which is called it as a static friction. Okay, what do you mean static friction? The friction which is developed when the body under rest condition. Okay, so here Fs is the static frictional force, and in that case static frictional force is equal to external force. Why? Because when you are applying the force on that, to balance that external force, the frictional force also opposes. So that's why here the P is equal to Fs. So external force is equal to frictional force, then there is no motion of the body, then it is under equilibrium condition. Okay. This is the static friction condition. In the static friction condition, Fs equal to P means Fs means static friction, P means external load. See, both are same. Okay. Now in the second case, let us move to the second case. Okay. In the first case, we have applied the force is P. Now in the second case, I am applying the force P1. So the P1 which is greater than P. Okay. Now I am increasing the force P1 which is greater than P. So now I am increasing the force further on the body. Okay. And at the same time, the friction force also furtherly increases. See here, when you are applying the force P, the friction force developed is Fs. Okay. Now you are increasing the frictional force. If you are increasing the external force, further force P1, the frictional force also increases. Fs max means maximum frictional force is developed to resist the motion of the body. Okay. So here the maximum force which is developed to resist the motion of the body is known as a limiting friction force. Okay. So that is the definition of the limiting frictional force. What is the limiting frictional force? The maximum friction force. See here, even you are increasing the external force to move the body, the frictional force also furtherly increases to resist the external force or to resist the motion of the body, opposite direction. So that's why Here, what is the maximum value reached? The maximum value developed. Okay, that maximum value developed in the friction, that is known as a limiting friction, that is represented with the Fs max. Fs max means limiting maximum static friction. So Fs max means the maximum value of the static friction is known as a Fs max. That simply we call it as a limiting friction. So even though it reaches up to the maximum frictional force, okay, so it resists the body. So that's why in the second case also there is no motion of the body. So that is Fs max is equal to P1. Okay, this one I uh, I will represent. Actually, it has to represent here. Okay, impending motion. Okay, at the point here when it reaches the maximum frictional force, that is the maximum static friction value, that is the limiting frictional force value. Uh, uh, Furtherly, the frictional force will not increase if you are increasing the further force P2. So in the P2 is which is greater than P1 and P. Okay. In the third case, you are increasing furtherly external force on the body. When you are increasing the external force furtherly on the body, now the frictional force also here it reaches already maximum value. Now after this point, it cannot increase furtherly. So that's why up to how much can withstand it. So it can withstand it. So after you are furtherly increasing, it will not withstand the, it will not oppose the body. So automatically that value will be reduced. So the reduced value and the motion of the body, that motion is known as a impending motion at the starting of the uh, 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 limiting friction value. Okay, so at the after reaching the limiting friction value, the value will not be further increases. The frictional value will not be increases to withstand the loads, withstand the opposite force, withstand the external force. So that's why automatically the frictional value when automatically it reduces, the motion starts. So that motion is known as a impending motion. Okay. So when the impending motion starts, impending motion is starts. It is a wedge of sliding and the wedge of slipping is started at when the frictional value reaches the maximum value. That is the Fx max, or it is reaches at the limiting frictional value. So in that case, the P2 is greater than Fk. Fk means kinetic friction, or it is also called as a dynamic friction. Why? Because what do you mean dynamic friction or kinetic friction? I explained already. The kinetic friction or the dynamic friction is a frictional force which is developed when the bodies are in motion. So in that case, the frictional value is less compared with the external force. So there will be motion. Okay. So this is about the limiting frictional force. In the first case, in the limiting frictional force, Fs is equal to P, means the frictional force which is developed is equal to external force. So in that case, there is no motion between the bodies. And the second case, the frictional force is reaches the maximum value to withstand the external force further increases. We are increasing furtherly external force up to P1. The frictional force also increases. So in that case also, no motion in the between the bodies. But Fs max is known as a limiting frictional value. The maximum friction force that can be developed at the contact surface when the body just on the point of moving. Okay. So after this point, the furtherly the frictional force cannot increases. Means it can withstand up to a certain limit. After the limit crosses, it can't withstand the external load. So that's why automatically the friction force is reduced. So that's why here the reduced frictional force is known as a kinetic friction. And the force is more when compared to the kinetic friction. So that's why when you are comparing the static friction and kinetic friction, which is the more value, static friction or kinetic friction. So the static friction is a greater value when compared to the kinetic friction. Otherwise, the kinetic friction is a less value when compared to the static friction. Okay. So this is about the kinetic friction and the static friction and the limiting friction. I think you understand very well the differences between the static friction and the limiting friction and the kinetic friction. Okay. And let us see the graph here. So how the graph between the friction and the external force. Here, let us say the graph summarizes the effect of regarding the friction, right? What is the effect? of the friction when you are applying the force, right? Here, let us take the force P along the x direction. See, this is the x-axis. Along the x-axis, I am taking the force P. And along the y-axis, I am taking the force, frictional force is F. Okay. Now, along the y-axis, the frictional force is there, and along x-axis, the force P is there. Now, let us see the first experiment. In the first experiment here, the frictional force. So, in this condition, you are applying the force P, and the frictional force developed is Fs. So, we are writing the starting when you are taking the values, the force and frictional force, you will get the same value. Why? Because in the starting here in the static condition means there is no motion, means under balanced condition. When the body are not moving means it is under equilibrium condition. Equilibrium condition means P is equal to F or Fs. So that's why here, if you draw the graph in between them, you will get a straight line in between them, right? Like that, the inclined, the straight linear curve, you will get a F is equal to P. Okay. So here F is equal to P. If you are taking these values, you are applying the force P and the frictional force also developed. So both are equal. The body under stationary condition. But it reaches the maximum value. That maximum value is known as a limiting frictional value. So when it reaches the maximum limiting frictional value, that is Fs max. Okay, this is the limiting friction value. Okay, so it reaches. See, this is the static frictional. Fs means static friction. Max means the maximum value of the static friction is known as a limiting friction. So this is called it as a limiting friction. Okay, and the right side of the limiting friction is a static friction. During the static friction, Fs equal to P only. Fs is also is equal to P only. Okay. Now it reaches the maximum value that is known as a limiting friction. Fs max is a limiting friction. After reaching this value, automatically the body starts moving, right? When the body starts moving, automatically this value will be reduced. So that value is Fk. Automatically it is reduced. See, Fk is the kinetic friction. Okay. Now Fs is a static friction, and Fs max is the static friction maximum value is known as a limiting friction, and Fk is the kinetic friction. During the kinetic friction, there is a motion, and up to the static friction, there is no motion. Okay, and impending motion in between them. So impending motion you can define as the movement at the point where the body is on the verge of sliding. See here, at that moment, there is a sliding of the body or the slipping of the body which is takes place. So when it is takes place, the body at the static friction reaches the static friction force is reaches the maximum value. See, the static friction is reaches the maximum value is known as the limiting friction. At the limiting friction point, the limiting friction point at that moment, at the point where the body verge of sliding or where the body starts to slide. So at that movement is known as the impending motion. Okay.